In the previous video we talked about fixed point iteration method, and we said that there is a necessary condition for successive approximations to converge, and that is the absolute value of derivative of g must be less than 1 in an interval. But then question arises that why is it a sacrosanct condition, that is why is it necessary condition. In this video we are going to talk about that why is it so. So in order to understand this, let us say that at x equal to alpha the function value is 0. In other words, alpha is the root, and this can be written in equivalent form as alpha equal to g at alpha. Now in order to reach to this root alpha, we start with some initial approximation. Let us say that initial approximation is x0. So the first approximation will be x1 equal to g at x0, and if I subtract equation 2 from equation 1, then I can write down it as alpha minus x1 equal to g at alpha minus g at x0. Now before proceeding further, hereby I would like to invoke one theorem called mean value theorem. And what this theorem says? This theorem says that if I am having a function g which is dependent on x, the function looks something like this, and the endpoints of this function are a and b, and I draw a secant from a to b. In other words, the secant passes through the endpoints. Then there must be a point in between a and b. Let us say that point is c, where if I draw a tangent, this tangent must be parallel to this secant. Remember, there could be one point between a and b, or there could be more than one points. So it means I can write down g prime at c, that is slope at c, is equal to change in g value from a to b when x changes from a to b. Invoking this, I can write down that if there is a point c in between x0 and alpha, then g at alpha minus g at x0 by alpha minus x0, or g at alpha minus g at x0 is equal to alpha minus x0 into g prime at c. This is equation number 4, and if I substitute this in equation number 3, I get alpha minus x1 is equal to alpha minus x0 into g prime at c. Let us say this is equation number 5. Similarly, I can write down alpha minus x2 is equal to alpha minus x1 at into g prime d, where d is between x2 and alpha, and if I continue it, so alpha minus xn is equal to alpha minus xn minus 1 g prime p, where p is between xn minus 1 and alpha. And if I multiply 4, 5, 6, 7, etc., then I get alpha minus x1 into alpha minus x2 into alpha minus xn is equal to alpha minus x0 into g prime at c, alpha minus x1 at g prime d into alpha minus xn minus 1 at g prime p, and I see that all these will cancel out. All these will cancel out. So what we are left with is alpha minus xn is equal to alpha minus x naught into g prime c, g prime d, and so on to g prime p. This is equation number 8. At this point, if I say that the absolute value of derivative of g is less than or equal to some value k which is less than 1. If is it so, then and this value is in some interval a and b, then I can write down absolute value of alpha minus xn is equal to absolute value of alpha minus x naught into k to the power n. This is equation number 10. And if n tends to infinity, k to the power n tends to 0. To understand this, let us say that value of k is 0.9 which is less than 1. So k square is 0.81, k cube is 0.729, and so on so forth, as we see that it is tending towards 0. So if the right hand side tends towards 0, we can write down that xn is equal to alpha. The nth approximation is alpha, that is our root. So we have seen here that why is it necessary condition for successive approximations to converge to the root. Now we are going to talk about that the root which we have got in interval a and b, how do we ascertain that it is unique root? That is, we are now going to talk about uniqueness of the root. In order to understand this, that let us say in an interval a and b, we are having two roots. One is alpha 1, so it is given by alpha 1 equal to g at alpha 1, and another is alpha 2. So as per iteration method, I can write down alpha 2 is equal to g at alpha 2. So alpha 1 minus alpha 2 is equal to g at alpha 1 minus g at alpha 2, which can be written as alpha 1 minus alpha 2 sum g prime theta, where theta is in between alpha 1 and alpha 2. So from this I can write down alpha 1 minus alpha 2 1 minus g prime theta is equal to 0, and as we know that when g prime theta goes towards 0, alpha 1 is equal to alpha 2. So it means we will get only one root, and that root will be unique root. So this we have seen that the root which we obtain between this interval a and b is unique. Now we will talk about that what is the error in successive approximations in fixed point iteration method. So let us talk about error. So let us say alpha is the root and xn is the nth approximation. So I can write down alpha minus xn is less than or equal to k times alpha minus xn minus 1, which can be written as k times alpha minus xn plus xn minus xn minus 1, or it can be written as alpha minus xn into 1 minus k less than or equal to k xn minus xn minus 1, or if I consider that alpha minus xn is equal to or less than some error, and this error is our tolerance. In other words, that this much error we can accept. So the error between xn and xn minus 1 will be less than or equal to 1 minus k by k into this error. So if I know that I have decided that what is my error beforehand, then I can find out that after how many iterations I need to stop the calculations. Once again, let me repeat that if I have decided that this is the tolerance, then I can ascertain or I can find out that after how many iterations I need to stop the iterations. So this is what, in other words, I can write down that after how many iterations will or do I need to stop iterations. Now let us understand the whole method with one example. So the example is x square plus sine square x minus 3 is equal to 0. We want to find out the root. So first of all, we need to find out the interval in which the root lies. So the easiest way to do is, let us say that this is the function x square plus sine square x minus 3, and I find out its value at x equal to 1. That will be 1 plus sine square 57.3 into 1 minus 3, that is minus 1.2919, which is less than 0, and at x equal to 2 it is 4 plus sine square 57.3 into 2 minus 3 is equal to 1.8267, which is greater than 0. In other words, it is positive. So the root lies between 1 and 2. Once I have decided, or I have found out that what region this root lies, let us start. So first of all, we need to write down it in appropriate form which converges to the root. In other words, that we need to write down this equation in x equal to g form, such that the derivative of g, or absolute value of derivative of g, should be less than 1 in this interval 1 and 2. So x equal to square root of 3 minus sine square x. This is what we have written. And let us see that what is g over here. G is square root of 3 minus sine square x, and so its derivative is 1 by 2 minus sine 2x by root over 3 minus sine square x, or if I look at this value, let us say at x equal to 1, so this value comes out to be less than 1. It means that the necessary condition is satisfied, and so the successive approximations will converge to the root. In addition, we see here that g prime is negative, and hence the successive approximations will oscillate about the root. Now let us start the iterations. So for that, let me say that x naught equal to 1 is my initial approximation. So the first approximation will be x1, which is at g at x naught, that is at g at 1 is equal to 3 minus sine square 57.3 into 1, and this 57.3 is a conversion thing, so that is 1.5139. this is what we will get, and from this I can find out the second approximation, and that is 3 minus sine square 57.3 into 1.5139, and this comes out to be 1.4153. x3 will come out to be 1.4226. x4 will come out to be 1.4218, and so we see here that if we continue like this, we will find out that x5 will be equal to 1.4219, and because these two successive approximations are same up to third digit, so the root is 1.421 correct to 3 decimal places. That is what we found out. Let us write down this equation in another form. Let us say that form is x equal to sine inverse square root of 3 minus x square. So what will be g prime here? The absolute value of g prime, that will be minus x by square root of 3 minus x square into square root of x square minus 2, and we see that this does not satisfy this particular condition. It does not satisfy the given condition for convergence. And what is that given condition? That given condition is this one. Hence the successive approximation will not converge to the root if we write down the equation in this form. This is what we need to understand. Now, one very important thing is over here, that in some of the methods, for example bisection method, the successive approximations remain within this particular interval, or in other words within this bracket. However, in case of fixed point iteration method, the successive approximations will converge even if we start with initial approximation outside this interval, provided that in that interval also this condition is satisfied. That is, the derivative of g, or absolute value of derivative of g, must be less than 1 in that interval also. So even if we start with the initial approximation outside the interval, let us say a and b is our interval within which the root lies, we can start from any value outside this. Only condition is that at those values also this particular condition must be satisfied, and if it is satisfied, then we can start with any initial approximation outside this interval as well, and they will converge to the root. So unlike bisection method, this method is not relying on, or the successive approximations are not dependent on this particular interval. We can start with any initial approximation, and that is why it is known as unbracketed method. And there are other unbracketed methods also, but this is also one of the unbracketed methods. In other words, this fixed point iteration method is an unbracketed method. So this example we have seen before also, that in previous video the example which I had taken, there we started with the initial approximation x naught equal to 0.5. There the root lied between 1 and 2, so this is outside this interval, and also we started with x naught equal to 7, that is initial approximation equal to 7, that is also outside this interval. But if in both the cases the successive approximations converge to the root. Why? Because at this point or at this point, or in other words in this interval also this particular condition was satisfied. So as long as this condition is satisfied in that interval, we can start with any initial approximation. This is an important thing to note over here.